C. Standard 12th Max Chapter 1 Applications of Matrices and Determinants. Exercise number 1.6 and the question number 1. In that we are going to do the third subdivision. The question is test for consistency and if possible solve the systems of equation by rank method. First you have to test for consistency. So already we have seen the consistent equation. Now let me going to introduce the concept of inconsistent. So what do you mean by inconsistent? See the system of equations have no solution. So in that case the lines are maybe parallel. They never intersect. If they intersect only, we'll get the solution, or they may be coincide. In that case you will get the infinitely many solution. So here inconsistent equation, they never intersect, they are parallel. Now let me do the system, solve the system of equation by rank method. If they are consistent only, we can get the solution. Okay, let me try the augmented matrix. AB is equal to, write the coefficients of the variable x, y, z. X coefficient 2, y coefficient 2, z coefficient is 1 and the constant is given as 5. And in the second equation, x coefficient is 1, y coefficient is minus 1, 1, 1. Third equation, 3, 1, 2, 4. So this is your augmented matrix. It's matrix A and this is matrix B. So let me do the elementary transformation and bring it to the row echelon form. So when you do this elementary transformation, first we must check whether the first element of the first row is 1. See here 2. So in that same column you try that whether they have, any of the row have the 1 as the first element. See the second row has the first element as 1. So let me interchange the rows here. R1 goes to R2 and R2 goes to R1. So 1 minus 1, 1, 1. 2, 2, 1, 5. See third you write as it is 3, 1, 2, 4. Okay. So next see how to bring this matrices. The second row, first entry should be 0. Keep the first row as it is. Second row, first element is 2. So in that case, you have to make the first row, first element as 2, multiply by 2. So I multiply R1 by 2 and subtract it from R2. So that is our new R2 row. So 2 minus 1 2s are 2, 2 minus 2 0, then minus 2 minus 1 plus 2, 2 4, then minus 2 1 minus 2, minus 2 plus 1 is minus 1, and then minus 2 plus 5, that is you will get as the 3. Come to the third row, again the first entry should be 0, 3. So I multiply R1 by 3 and subtract it from R3. This is your new R3 matrix. So row. See 1 3s are 3 minus 3, 3 minus 3 is 0, minus 3 minus 1 plus 3. So 1 plus 3 is 4. and then minus 3, 2 minus 3 is minus 1. Then 4, this is minus 3, 4 minus 3 is 1. So this is the resulting matrix after that elementary transformation. See, again you have to bring this matrix in the row echelon form. So first row you keep as it is, second row just keep as it is. In the third row you have to get the first two entry as 0. So already 1 as 0. You see the second element 4. You compare it with just the previous one of the second row. So that also 4. So if I subtract, I will get 0. So our R3 row is R3 minus R1. R3 minus R2. 0 minus 0, 0. 4 minus 4 is 0. Then minus 1 minus, so that is plus 1. Minus 1 plus 1, 0. This is 1 minus 3, that is equal to minus 2. So when I make the second entry of the third row as 0, automatically third one is entry becomes 0. So now you look at the rank of the two matrix, that is one is rank of A, B matrix. Rank of AB matrix is full matrix here. See the last row you have one element. It has 3 rows. In each of the 3 rows we have the non-zero element. So rank of AB is 3. And come to rank of A matrix. This is 3 by 3 matrix. Look at the rows. See the last row, all the entries are 0. So first row with the non-zero element, second row with the non-zero. At least one element should be non-zero. So in that case, it has only 2 rows. The third one, all the entries are 0. So rank of A is 2. So rank of AB and AB is not equal to rank of A. Rank of A. So in that case, we say the system is inconsistent. System is inconsistent. That means it has no solution and has no solution. No solution. That's all. So when they are given the test for consistency, so the system is inconsistent, therefore it has no solution. Thank you.